Let us tell you about John. He is a hard-working guy who barely has time to spend with his family. So for the holidays, he carefully plans a journey for all of them to make good memories. They have decided the destination would be beautiful Croatian shore. Everyone in good mood set off, not paying special attention to all of the road signs informing about mines and unexploded ordnance. Rented apartment is beautiful, even with backyard for kids to play. But then John doubts the safety of the area. So he simply grabs his phone equipped with special SAPER application, scans the ground and learns that there is no explosive in the area. Now he knows there's nothing to worry about. SAPER system provided him with state of intact security. War as an organized armed conflict typified by extreme aggression is identified as 6 of 10 biggest problems that national society is facing currently in 21st century. This is an outcome of almost 1,000 armed conflicts that occurred in last 100 years. Yet we still have to deal with not only political and physical, but also ecological and psychical outcome of war. Unexploded ordnance and landmines left in the ground are still killing and injuring civilians, making area of Skaful impassable and unusable for decades. According to NATO and UN reports, during last 10 years there were more than 240,000 unexploded ordnances victims reported. 2,000 people are involved in landmine accidents every month, 1 person every 20 minutes. 40% of victims died, rest remain maimed for all their life. There are approximately 100 million active mines scattered in over 60 countries all over the world. Average mine costs from $3 to $30. However, removing just one of them can cost 50 times as much. The UN estimates that with current technology, it will take nearly 100 years to clear all the mines in the world. United Nations classifies coping with conflict casualties and unexploded ordnance as one of 10 significant Millennium Goals. Its impact factor manifests itself through hundreds of victims across the world, both minors and adults. Nowadays, unexploded ordnance and landmines remaining after war conflicts are one of the toughest problems governments and army is facing. The biggest part from all of NATO and UN operations are peacekeeping operations, which are directed to help civilians. Simple and innovative solution for most of these problems is our application for smartphones called SAPER. The world population is estimated to number over 7 billion people, while the number of mobile phones already reached 4 billion. Mobile phone became our main personal device. Human population spent more and more time using all of the mobile devices' features. As researchers show, we use mobile devices twice the amount we spend eating and over 1/3 of the time we spend sleeping each day. This is the sign that mobility became an inseparable part of our life. Every smartphone is equipped with many sensors. One of the significant is magnetometer, which is used as an electronic compass. But in some cases it can be disrupted. That observation led us to our finding. Magnetic field distortion is caused mostly by close presence of ferrite-based objects. The question is, if by using sophisticated algorithms we would be able to detect unexploded ordnances located beneath the surface of the ground? The answer is yes. There are lots of already existing mobile applications built for metal objects detection, but SAPER differs from them. It can be easily confirmed by doing a market research. We downloaded and tested other applications on the nearest ferrite-hosted item. They all represented different types of graphical interfaces, not always easy to use, not always well developed from scientific point of view. Our product takes it much more further. It combines scientific research from several domains: magnetic detection, electronics, sensor fusion, and artificial intelligence. That is why we can speak of conceptual innovation in case of SAPER. All patterns stored and described in our system are used by specific recognition algorithm, detecting magnetic field disturbances caused by objects placed in the ground. By method of magnetic signatures comparison using neural classifier, we differed nearly 40 patterns of commonly used UXOs. Our knowledge base is filled with particular explosives data collected at laboratory as well as in field conditions. SAPER patterns are adaptively extended through the mobile application usage. Designed multi-layer backpropagation perceptron consists of 3 layers: Each pattern is divided into grid-based data representation. The learning process takes place each time a new and not recognized pattern is sent from smartphone into a server. In some cases, a classifier is assisted by rule-based reasoning in order to adjust initial scanned object parameters to template-like form. The use of built-in magnetometer is problematic due to inaccuracy of recognition caused by measurement errors. The usage of external magnetometers or simply professional metal detectors is another way of increasing the accuracy of our recognition, but the size of such devices excludes their possible use in mobile solutions. This is the reason that we have been working on our own self-made hardware magnetic sensor that would meet all the expectations associated with the accuracy and size. Our device is based on ARM magnetometer equipped with additional support for accelerometer and electronic gyroscope. Our project has been developed using Cortex-M3 ARM-type microchip, which performs signal filtering and Wi-Fi wireless communication support. To extend even more the innovative side of our project, we have experimented with utilizing augmented reality for threat detection using the external magnetometer. In such scenarios, smartphone is used for visualizing investigated area based on GPS position, current smartphone orientation, and external magnetometer. Projected view summarizes the information and helps user to properly investigate the area.
Zastosowanie najpowszechniejszego urządzenia dzisiaj elektronicznego, jakim każdy dysponuje praktycznie, nawet w tak odległych krajach jak Irak i Afganistan, czyli telefonu komórkowego z odpowiednimi aplikacjami i współpraca z technologiami znanymi chociażby z portali społecznościowych, otwiera tutaj całkowicie nowe możliwości, które na pewno warto przetestować, a już największym błędem by było nie skorzystać z tej okazji.
The designed architecture utilizes good practices in software engineering and multi-layer client-server systems. It has been developed as model view controller designed pattern, separating the presentation layer from processing logic and data model. SAPER consists of server facilities integrated with pattern recognition and artificial intelligence mechanisms. Client side consists of mobile and web users. Mobile application is key component of the system, serving as threat recognition tool, notification assistant, and magnetic pattern recorder. Web browser access delivers direct insights into UXO knowledge base and recorded and recognized incidents. Interoperability is key technological advantage of our system. Therefore, marine technologies had to be used and integrated in SOA environment. .NET platform plays the key role in our solution, but we required also open source libraries like Waka and Protege for pattern recognition and artificial intelligence support. Microsoft Phone platform delivers among many features voice guidance and push notification service support. Developed architecture supports also Azure deployment strategies, making our solution scalable and efficient for the future. Our application complies to Metro style guidelines. Interface has been designed to imitate real device, ground scanning sonar. This makes the use simple and intuitive. It also allows inexperienced user to do all the needed tasks in only 4 short steps. The main idea of the application is to simplify the complex operations associated with pattern recognition. Most of our design was firstly created using modern and advanced tools for computer graphics. We also utilized pixel art techniques, which are commonly used in game development for visualization of magnetic potential well. All the used methods increase the application's efficiency and user's experience. Use of the application consists of sweeping the device above the scanning grid-like area. During the act, specialized algorithm gathers data from magnetometer sensor, displays the image of magnetic potential well using 2-dimensional graphs and 3-dimensional plot. The information is then sent to cloud-based reasoning system, which compares image reflecting intensity of magnetic field with stored knowledge. As a result, the user receives percentage probability of pattern matching. Another useful feature of our system is possibility of receiving notification about close, recently reported threats. Information contains location of the explosives and level of estimated danger. The notification is sent only to users located in the range of 10 km from recorded unexploded ordnance. All notifications about threats are filtered by users' last known location. SAPER integrates also with the social media, including the most known channels like Facebook and Twitter. The information comes with location of the threat and identity of the reporting user. Additional notification channel is established through the message channel. Another possibility is to inform specialized military patrol using military command and control system by sending NATO standard format incident report. The standardization of notification results in quicker reaction of neutralizing patrol. Laboratory experiments were a significant part of the project due to gathering data for knowledge base. Our patterns were created using real explosive devices. Some of the landmines were actually dug in the ground to confirm that our solution is working properly. As we were scanning the real devices, it recognized already existing patterns. Web portal was also designed according to Metro guidelines. It displays the map of the stored threats locations. Moreover, on the left we can see the list of recently detected explosives. There is a number of options to choose, starting from information about the user, unexploded ordnance, location, patterns, associated knowledge bases. The web portal also provides notification possibilities like emergency call for clearing landmines patrol, social media including Facebook and Twitter, military command and control systems, text message notification. Choosing first option results in demonstrating threat reporter's profile. The second one affects in displaying detailed information about the explosive. We believe SAPER should be delivered as a free and open tool. For this, we propose two separate ways of business development. For first, availability of advertisement placement and micropayments will be the core project's income methods, favoring widespread users. We predict active 10,000 users at the end of the first year. The application and portal usage will be mainly concentrated on threat notification modes and threat information broadcast. Extended messaging services and expert assist modes will be charged in form of micropayments up to $2. Some of detailed recognition results and server functionalities will be only available for registered premium users which have purchased our external magnetometer sensor and telescopic arm with grip. The estimated development and maintenance costs will be mainly connected with the cloud environment cost and software upgrades. We will concentrate on research and improvement of our pattern recognition algorithms along with mobile application porting. We made few economic simulations to estimate the project's return of investment rate and came up with a number of over 700% after 5 years. Calculations have been made in Microsoft Project and modern methodologies such as RUP and Prince2. Second business strategy is connected to non-governmental organization support for post-conflict areas. All costs would be held by peacekeeping organizations like UN, European Union and NATO. Their application will be preloaded in all of the smartphones in the location of the delineated area due to collaboration with GSM operators. This strategy is dedicated to poor people of regions affected by conflicts.